Hello, we are here for one more lesson of this T-Flex CAD training course, and the topic for today will be the engineering optimization. So the idea in this lesson is to show you a functionality we can find on the basic CAD package uh, that allow us to solve engineering problems in both 2D or 3D. We have constraints and we can work with these constraints on the model variables that we've already spoke about in these past lessons. So I've opened a drawing that is installed or pre-installed on the standard installation of T-Flex, and in this drawing we've created variables that have things assigned. In this particular case, we have angles and a perimeter. And the idea is to work under this or working on this belt length. Okay, so we can come to this parameters menu, then optimize. We have this dialog box. So before I run the function, I can go to properties to see the main dialog box. And you see that we can work around several things. So we can work around this, minimize, maximize, or make it equal. We can work in some of the variables that we may have, in this particular case the parameter, give it a tolerance. We can insert limitations in case we want, and on the variables we can give variables according to the processing window, so minimum and maximum. And then we can run this calculation under certain algorithms. Okay, so when I do the run, it will calculate something. The idea is to minimize the belt length, maintaining the positions. So it has made this calculation. So it changed the position of these elements, and the belt length reduced from 706 to 530. So this is the kind, going back, okay, this is the kind of calculation that we can do with this function. Okay, so now let us create a very simple example to show you how to work with this. So the idea now is to create a figure. Let us do something, for example, with 50 mil, and I will create 4 circles. For example, I will say 30. First, I will create a variable C1, 30. Another one in here, C2, 30 also. Then C3, the same. And then C4 and also 30. Okay, and now I will create a graphical line with the functions that we already know. Okay, so through this point to this one and going also to this point. Okay, now I will create a edge. I will look for the automatic mode, so in here, create it, and that's it. On the variables, if I call the dialog box, I have these 4 variables. I will create one additional variable to calculate the area of the hatch. So first I will go to measure. I will go to in measure, click on the entity. Okay, look for the one of the properties, which is area, and for the area I get this expression. I will copy it, and now parameters, variables, one additional variable, area, with this expression, and OK. That's it. So V again. So you see the area of this is 2925 whatever. Okay. So the idea now, if I go in optimize, it is to create a new task. I will call it area, and I'll try to make it equal through the area to 9 to 5. I will say to 8. Let us put a big tolerance, so 1. And working on the variables, I will say C1. I'll try to say from the radius is 30, so I will say from 20 to 40. On the, I will say not C2, but I will on the C3, I will say from 15 to 35, for example. Okay. And I have a couple of things around here also to explain you. First, it is the type of calculation that we can use. Basically, we can have several calculations. The first one, the user will run only when I press the run button. Okay, it's very easy. The second one on optimal model regeneration. This is a half mode that I can call it. It will run upon partial model regeneration, and this last one will run upon full model regeneration. Okay, I will say user, and we have several algorithms. Okay, that we can say the steps, and according to the things we choose, this will change. For now, a brief explanation saying that the fast search is a method that is very suitable for functions with one or two extreme, and the dichotomy is suitable for functions of just one variable. Okay, and we can say the number of interactions and so on. Let us keep this on the fast search for being easier. So just OK and run. Okay, so you see it changed the radius of the C1 and the C3 to find this value that I've input inside the tolerance that was 1. So OK, that's it. And see the difference? Okay, it changed what in his opinion was correct. So this is the idea for this functionality. I think it's very interesting, and we have many different examples where we can apply this kind of functionality. So these were two very easy examples, one pre-installed, the other one that we've created. I'm not sure, or I hope that these examples were clear enough to show you the potential. But anyway, if you need some kind of help in this function, you know how to reach us, and we'll try to help according to the cases you may send us.